grace this wonderful occasion. Also, I would like to express my heartfelt gratitude to the organizers of the event as they have given me this honor of presenting my idea at this great platform. So, I am Ariman Sharma, and today I am here to talk about a topic which many people consider as an abstract one, known as infinity. Now, a note of caution here. Sadly, today when I'm saying infinity, I do not intend to speak on Marvel Avengers Infinity War, uh, although I would love to, but today we would be talking about infinity in the domain of mathematics. But trust me, it is also going to be a beautiful journey. So let us start. But before we talk about our thought, our intuition behind the Cardinal approach to infinity, we first need to understand what do we exactly mean by infinity? How we can define it? Now, one of the common definition of infinity that we can have is that it is something which is endless, it is boundless, limitless. These are synonyms. And I can also say that infinity actually corresponds to something which is unassignable or unexpressible, and that is greater than any countable number you can think of. If I talk in a bit philosophical way, I can say that infinity is something which is beyond our imagination. Now, let me tell you that the value of infinity has always been a topic of fascination for mathematicians and philosophers for many, many centuries. Now, if I talk about ancient Greek philosophers, they were at first a bit skeptical about how they can address the concept of infinity, and they often ignored it. Euclid can be considered as the very first mathematician who tried to address infinity in the way it is, through his postulates. Now, talking about the symbol that we use for infinity, well, it was given by Sir John Wallis, a very renowned mathematician in the year 1656, and it is known as lemniscate. Now, as I have mentioned earlier also, there have been a lot of work going on around infinity. So I would like to highlight one important work in this topic, and that was actually given by my idol, one of the greatest mathematician of all time, Sir Srinivasa Ramanujan. He came up with his summation in which he stated that the sum of all natural numbers, right from 1 to infinity, that is 1 plus 2 plus 3 plus 4 plus 5, all the way to infinity, would give us minus 1 by 12, astonishingly. Now, I would definitely request you to kindly have a look into it so that you can understand the intricacy and the beauty of mathematics as a form of an art, as a subject. Now, it is not only that infinity is important in mathematics only, it is a very important concept in theology as well. So, there's a lot of significance that infinity have if I talk about religions, for example. Now, if I talk about symbol of infinity, well, it also stands for eternity. It also represents eternity. And if I talk about religion like Hinduism for that matter, then there's a mention of infinite cycles of birth and death until we attain moksha or enlightenment. So to sum it up, infinity is a very important concept in not only mathematics but in philosophy as well. However, today we would be talking about a mathematical aspect of infinity, in which we would state that infinity has dual aspects. Now, what do I mean by that? Well, what I'm going to say today is that infinity at the same point of time can be a point and it can be a line. Just like light, you see, earlier we stated that light travels in the form of particles. Then we stated it travels in the form of waves. And then we realized that light is nothing but a wave of particle. So just like that, infinity too has dual aspects. And that we are going to understand through the cardinal approach to infinity. So let us start. So starting with the assumptions, The very basic assumption I made is that infinity can be expressed in the form of a number, and the value of infinity tend to differ for different set of numbers. It is defined differently for set of natural numbers, rational numbers, and so on. Now we would look like now we would look at how infinity would look like. So since we have assumed that infinity is going to be a number, I can say that it is going to be the largest of all numbers and nothing would exceed that value. So with that notion, let us try to answer some basic questions. Now, which is the largest one digit number? We all know it is 9. Similarly, the largest two digit number, it is 99. Largest three digit number, it is 999. Largest four digit number, it's 9999. So you see that there's a pattern here. And in fact, we can generalize it. And I can say that if you ask me, say, which is the largest n digit number, I am going to say that it would be of the form 999, where 9 would be repeating n number of times. That is exactly how infinity would look like. So please note that here we are saying that infinity would start with 9. In between, we would have lot many nines. And although we know that infinity does not have any end, it is boundless, it is limitless. But hypothetically, if it is going to have any end, then it is going to be 9 only. There is no other number that can satisfy the condition. Now, since I'm going to say that this is going to hypothetically end in 9, then I have some hypothetical deductions as well. By that I mean that infinity is going to be an odd number. And because it is going to be an odd number, I can say that it can be expressed as the sum of an odd and an even number, and it can be expressed as the product of odd numbers. Both of these are actually the properties of odd numbers, and we have applied it to infinity. Now, talking about the fourth deduction, I'm saying that infinity is divisible by 3 and 9. Now, please note that in our approach, infinity divided by a constant, say k, would give us infinity, but of a different degree. We will talk about degrees of infinity later on. Now we will talk about the total odd and the total natural numbers that exist in the universe of mathematics. But before we start, we need to understand that how many natural numbers are there in the universe. Well, there are infinite number of natural numbers. And as per our approach, infinity is nothing but 9 bar. That is 9 repeating n number of times. So infinity is equal to 9 bar. I can say that. Now, to understand it, let us consider the first 5 natural numbers. 1, 2, 3, 4, and 5. Now, how many of them are odd numbers? Well, 3 of them are odd numbers. That is 1, 3, and 5. And similarly, we have the total even numbers as 2. That is 2 and 4. So here also, we can generalize it. And I can say that if I'm given the first n natural numbers, such that the last number given to me is an odd number, then I have the total even numbers as n minus 1 by 2 and the total odd numbers as n plus 1 divided by 2. Also, you need to note that the total odd numbers would always be one more than the total even numbers. So with that, let us move ahead. So the total even numbers is given by the formula n minus 1 by 2, which we have seen. And when we substitute 9 bar, uh, pardon me, if we substitute n as 9 bar, we would get it as 9 bar minus 1 by 2, which would be 9 bar 8 divided by 2, which would be 4 9 bar. Now, using this number, we can actually determine the total odd numbers, as one more than the total even numbers, which would be nothing but 1 plus 49 bar, which is equal to 50 bar. So let us move ahead. Now we would talk about the summation of all natural numbers and how it would look like. Now, as per our idea, as per our thinking, it is going to be an even number. Let us see how. Now we know that the total even numbers are 4, 9 bar. And again, if you do the analysis here, I can say that it is going to hypothetically end in 9, which means it is going to be an odd number. And we know that when we sum up odd number of even numbers, that is 3 even number, 5 even number, 7 even number, and so on, we know that their summation is always going to be an even number. Thus, I can say that the summation of all even numbers would be an even number. Similarly, by the same understanding, we have the total odd numbers as 50 bar. And now, when we analyze it, we can say that it is going to be an even number. And we know that when we sum up even number of odd numbers, that is 2 odd numbers or 4 odd numbers or 6 odd numbers and so on, we know that the summation is an even number. So when I combine these two results, I get that the summation of all natural numbers right from 1 to infinity is nothing but the summation of all odd numbers and the summation of all even numbers, which is nothing but summation of an even number with an even number, which would give us an even number. Now we would understand this very same question of the summation of natural number using our other theory, which we call as the fallout number theory. But before we understand what fallout numbers are, fallout number theory is, we first need to address that what fallout numbers are. So I can define fallout numbers in the following way, that it refers to a set of numbers that can be expressed as the product or summation of a constant with infinity or a degree of infinity. These numbers, just like complex numbers, do not exist in the world we live in the universe of mathematics. But by doing a little bit of analysis, we can actually determine the properties of these non-existing numbers. And how we are going to do this? Well, it would come under the fallout number theory. Now, let us do a thought experiment to understand the fallout numbers and the fallout number theory. Suppose you are standing at point A, that is 1, and you would like to go to point B, that is infinity. Now the question is, would you ever be able to reach point B, that is infinity? No, you would never be able to reach. But now consider a hypothetical situation that you traveled at the speed of light, there was time dilation, there was some white magic that you did, or who knows, in fact, you can do black magic as well, and you are standing at point B, that is infinity. Now the question would be, what is in front of you? In other words, what you would see after infinity? Well, it would be nothing. It would be a total blank space. And it is based on a common understanding that nothing exceeds infinity. So even if we would like to move one step ahead of infinity, we are going to fall. And that is exactly what we refer to as fallout numbers. So the set of hypothetical numbers are termed as fallout numbers. Now talking about the determination of property, well, I know that infinity plus 1 doesn't exist. But I can say that if it had existed, it would have been an even number. How? Well, since we have stated in our theory that infinity is going to be an odd number, I can say that a number just after an odd number is going to be an even number. Thus, infinity plus 1, although it won't exist, but it is going to be an even number. That's a property of it, and that is what we refer to as fallout number theory. So, with that understanding, let us try to answer the question we raised of summation of all natural numbers being an even number. Now, we know that the summation of first m odd numbers is given by the formula m squared. And as per our approach, as per our idea, the total odd numbers are 50 bar. Thus, I can say that the summation of all odd numbers would be 50 bar into 50 bar, that is nothing but 50 bar squared, which would give us 250 bar. Again, as you can see, this number would also have 0 continuously going on, and I can say that hypothetically it is going to end in 0, which would imply that it is going to be an even number. Now, we know, going by the same logic, we know that the summation of m even numbers is given by the formula m into m plus 1. And as per our idea, we know that the total even numbers are nothing but 49 bar. So I can actually get the summation of all even numbers from 2 to infinity minus 1 as 49 bar into 49 bar plus 1, which would be 49 bar into 50 bar. Please note that this product can also be simplified and we would get a number, but just for the sake of this lecture, I have not done it. But the result you would get would be that this number would also tend to end in 0, which would imply it is going to be an even number. Thus, when I combine these two results, I get that the summation of all natural numbers from 1 to infinity is going to be an even number. Now we would talk about the degrees of infinity. Now for that, let us consider the first 9 numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, how many of them are natural numbers? Well, all of them are natural numbers. But if I ask you, how many of them are odd numbers? You would say that there are 5 odd numbers, 1, 3, 5, 7, and 9. So if I take a larger set of numbers and I keep on increasing the cardinality of that set, I would find that although the number of natural numbers that exist in a universe and the number of odd numbers that exist, they both would be going towards infinity, but they would be going to different degrees of infinity. Also, you would note that at a point of time, the total number of odd numbers would be roughly half as compared to the total natural numbers that we would have. And that is why we have the idea of degrees of infinity. So on the basis of that, we have assigned value of infinity for different set of numbers. So the maximum value we can have in the set of natural number is 9 bar. The minimum value we can have in the set of negative integer is going to be minus 9 bar. And the maximum and the minimum possible value we can have in the set of rational number is going to be 9 bar, 0.9 bar, and minus 9 bar, 0.9 bar. Because in rational numbers, we have the element of decimals also coming into the picture. So with that, I end my presentation, and I would like to sincerely thank each one of you for attending this session. Thank you very much, and it was once again a very big honor for me. And once again, I would like to thank the organizers of the event for giving me this opportunity to share my idea.
Okay, thank you. 1 minute. Yeah, thank you so much for that. It was very interesting, but also short. I think we wanted more. But I think we can open up for questions now. We actually have a lot of doubts.
Definitely,
Uh,
we
so
can.
whoever has a question, you can unmute or put something on the chat. So just to clear it up for everyone, can you redefine what bar is when you said 9 bar and 5
All
bar?
right. Yes. Okay. Okay, Sitara. So what I mean by bar is that we would have that number repeating many number of times. So I would give you this example. Here I have used 50 bar. So it means 5 is like repeating only once. It is not repeating actually. And just above 0, we have this horizontal line.
Hello?
It actually symbolizes that 0 is repeating n number of times. It would continue repeating 0, 0, 0, 0 like that. So that is what I mean by bar.
Got it. Okay.
Now, I would request that if there are any questions which anyone would like to ask, please feel free to ask, and I would be more than happy to answer them, and I would try in the best of my capacity to answer it as a student of mathematics. So, anyone, any question?
Hello, good evening.
Good evening. Good
Yeah,
evening.
yeah. So I'm Anirban, and I had a question. The
Yes.
thing is, you started off by stating the biggest number for
Mhm.
each number of digits, right? Like biggest number for
One digit.
one digit, yeah, it will be 9, and then the biggest one for two digits will be 99, and all that things. But
Yes.
when we are trying to cover infinity, wouldn't it make sense that we also, when we start our argument by saying that the biggest number for a the biggest two-digit number is 99, wouldn't anybody be able to say that, well, we have a bigger number than that, and that is 100, which is a three-digit number.
Yes.
So why wouldn't we consider infinity as 10 bar?
All right. Okay. That's a very
Yeah.
good question. And I was looking forward that someone is going to ask this. So, how I can explain it? Just give me a moment. I'm going back to that slide. Uh, where is it? Yes. Okay. So here, first thing which I want to highlight here is that I have never mentioned about a number of digits infinity would have. Right. What I am saying here is that it would be of this form. It would be 999 continuously going on. And now, of course, now infinity plus 1, if we think on that line, infinity plus 1, then we know that there's nothing that would exceed infinity. And that has been addressed in the fallout number theory, that if we tend to go infinite, if we tend to go beyond infinity, we would have that set of hypothetical numbers coming into the picture, which are very much similar to complex numbers. They do not exist. So technically, we won't be going ahead, right? And now the point which I want to make here is that here I have used the notion of bar, like 9 bar. So what I'm saying here is that 9 would be repeating lot many times. It won't be a fixed number. It would go on and on. So technically, if you try to find a number which is just after it, it would be difficult. It would be difficult. So there
Yeah.
won't be that case inversion.
I Yeah, got
Yes,
it.
yes,
Yeah, yeah,
yes.
yeah. So one more important thing that I noticed is that to define the number 9 bar or 99 and the bar over 9, we use the concept of infinity itself to define the concept of the bar, or uh, to write down the thing that 9
Yes,
is being repeated an infinite number of times, and that is the
yes.
concept itself. So wouldn't that create some kind of paradox that we can't define that thing?
Well, that's a very good
Yeah.
point, and that's why, like at the very start, I highlighted that today I am going to share my idea, my thought, my intuition. I haven't used the word research anywhere, but this is more of a thought. This is an idea. So see, like the basic point is that infinity, like all of us, like none of us have actually seen how infinity would look like. We all agree that. So it is quite possible that how you view infinity, it is quite difficult. It is quite different from how I view infinity. So today, like what I highlighted is that this can be one aspect of infinity. Now you can think of it as, suppose if infinity is a face of a person. Now what I'm saying is that his or her eye can be like 9 bar. It would be like 9 would be repeating n number of times. Here I'm not using the term infinity to explain infinity. I'm just saying 9999, and it would go on. That I'm saying. The other aspect of infinity can be the symbol that we use for defining infinity. That is lemniscate. And the third one, as I mentioned, was given by the mathematician that uh, the the very famous mathematician Sir Ramanujan, and he came up with -1/12. So that can also be infinity, because if you look at what Sir George Cantor said, again a very big mathematician, he said that infinity can come in different shapes and sizes. So there's no point that I can say that this is the ultimate truth. You all should believe this. No, there can be different values of infinity. And that's why I introduced the notion of degrees of infinity. So, like it is, they can be lot values of infinity. We can have infinite values of infinity for that matter. So here, the notion that you stated that I'm using infinite word, I would not say totally that I'm using the word infinite. I'm just saying that it would repeat n number of times and it would be of this form. That's it. That's what I want to say.
Okay.
Yeah.
Thank you. Good idea, man.
Thank you. Thank you very much. Anyone else who would like to ask?
So would you like to comment again on fallout numbers? So basically you're saying if we look at infinity as a number, then
Yes.
any number that comes after that is difficult to define, or that's we would categorize it as something similar to imaginary numbers. Is that right?
Yes, yes. And that is what fallout numbers are. So I have given that example also that you are on a road and you would like to go to point B, that is infinity. Now, first of all, like we would never be able to reach it. But again, if we consider a hypothetical situation, because this idea is totally based on a hypothesis, it is based on assumptions, it is based on hypothetical situation. So in that case, if we tend to reach point B, that is infinity, then we would have nothing more left to move. Like we won't be moving ahead. And I think the basic idea why we need fallout number theory is basically to address the point aspect of infinity. When I started, I said that there are dual aspects to infinity, the line aspect and the point aspect. So to understand the point aspect, we need fallout numbers. And that's why we came up with the fallout number theory, which can be defined as a different set of numbers. So that is it. Yeah.
Do you categorize infinity as a number, or do you call it simply an idea? Like I think the problem is, like you said, the sum of odd numbers is also infinity, and the sum
Mhm.
of even sum of natural numbers is also infinity. But there are different degrees of infinity, right? And we
Yes.
call both of them as infinity. So it's more of an idea and less of a number, right? Not really.
So there are different degrees of infinity. I said it, and it is not that I said it. It was Sir George Cantor in his set theory he mentioned it about large cardinals. Although I would be very honest, I did not have that much understanding of set theory because I am in my first year, so I did not have that much understanding of it. But one thing which I can say is that infinity can come in different shapes and sizes. And the basic idea, like first of all, there is an element of if here. We first need to understand that here I'm saying here I Aravind Sharma is saying that if there's an element of if here, that if infinity is going to be a number, it would have these properties. That is what I'm saying. Now, whether it is true, whether it's not, well, it would require further mathematical analysis. So I'm working on it, and this is an ongoing project which I'm working on quantifying the value of infinity as much as I can. So now, right now, we have these two ideas going about infinity. One is that we can treat infinity as a concept. The other one is right now what I have stated is the numerical way of expressing infinity. So I'm working on the latter because in former we have made a lot of progress. And if we can actually quantify or to a certain degree, if we can understand what infinity is and how it would look like, it would be a great thing to understand. Yeah.
Aryaman, I have one doubt. So anything that comes after infinity is a fallout number. So that means we can also say that infinity plus one is an infinity, right? Infinity plus any number is infinity. You can tell that, no?
That's a very beautiful thing that you stated, and I would completely agree. But provided that if we address infinity as a concept, because I think when we were kids, like we all stated that infinity plus a constant, it would give us infinity. Infinity multiplied by a constant, it would give us infinity. But right now, what I'm saying is that if we address the point aspect of infinity, now what I mean by point is that 999, it is a point, but the line aspect is also highlighted here, which would be that 9 is repeated n number of times. So that is what that is why we use the concept, the notion of fallout numbers to address the point aspect. So anything before 9 bar, like any number we have 1 2 3, that is well defined. But anything after it, if we treat infinity to be a point, particularly, then it won't be defined. And that is where we need another set of imaginary numbers coming into the picture, which we call as the fallout numbers. So hope that answers your doubt that, okay, we cannot say it because there's a limit to it. So actually what we are doing in this theory, because we have stated that infinity is going to be a number, we are doing, to a certain degree, we are doing arithmetical operations with infinity. Yes, we are saying it. But at the same time, what I want to say is that, this we are giving, actually, we are limiting the concept. We are limiting something which is limitless. And how we are doing it, that is addressed in this numerical way. If we address infinity as a number, so infinity plus 1 won't exist, actually. It won't exist. So it cannot be infinity. It would be a fallout number. You cannot define it.
Okay, Aryaman. Okay.
Thank you. Yeah. Any other question? Anyone who would like to ask?
I think it's a very interesting and beautiful concept that you've come up with, and it's like giving a boundary to the idea of infinity, right? Like you said, limiting something that is defined to be limitless. So
Yes.
please do
Yes.
work on it further so that you can take it forward, and we'll definitely from
Definitely.
our side try to, I think, bring more people who have more expertise in pure mathematics who can offer some insights to you as well.
It would be my pleasure. And just to say one thing is that in philosophy, like I can link it to philosophy as well. We have, like, we have actually never, like, if those of you who believe in God, actually, I can say that none of us have actually seen God, but we have given form to uh, how God would look. So just like here also, none of us have actually seen infinity, but we have given form to it. We are limiting it in some way or the other. So it is, as of now, I would say that it is more of an idea. It is more of an intuition that if we think about quantifying infinity, we can get some brilliant results. And I, as a student of mathematics, I believe that, like, mathematics is the language of the world we live in. So anything, you name anything, we can express it in a numerical way. And it is not what I'm saying. It was Sir Galileo Galilei, the father of modern physics, who stated that measure what is not measurable, and work on it. So that is why I have came up with the cardinal approach to infinity. So that is my concluding remark. And with that, I would like to end my presentation. Any other question anyone would like to ask, please feel free.
I
Anyone?
have another one.
Yes, yes.
You showed how infinity would look like if it is a rational number, no? Like
Mhm.
99.999 bar. That.
Yes,
But
yes.
so how would infinity look if it is an irrational number?
Oh, that's a very good question. And I think that is, to be very honest, that is a basic limitation that I'm having. And I was encountering this. I tried assigning the maximum and the minimum value we can have in the set of imaginary numbers as well. So that is something which I can say it as an imaginary number inside an imaginary number. I can say it in that way also. So I think these are certain limitations on which I'm trying to work upon, how I can define it for the set of irrational numbers and so on. And whenever, like, if I have that progress, I would definitely be sharing with all of you, and I would love to get responses. Uh, Either it's for the study, or either it's for some general kind of rule or anything. I would love to hear from you, and I would be needing your guidance to excel in this field of study. Definitely.
Thank you. That was amazing. And yeah, keep working on it. I think the question that Sagar asked is going to play an important role in how you develop this idea further. So
Yes.
the 9 bar that, for example, you showed is an approach you can take only for rational numbers. Is that right?
Rational and natural numbers and negative integers. That is what right now we are confined to work upon.
Okay.
Irrational numbers and imaginary numbers, these two are left. These
It
two
kind
are
of breaks down for irrational. Yeah.
yes, as of now, yes, because as I stated that it is an ongoing project, and
Hmm.
I came up with a quadratic equation also which has infinity as roots. So, but that was not. Uh, I would not. I would say that it was not that much developed, and I was getting some conflicting results. To be very honest, so I have started working on devising the to take it to algebra as well. Apply it somewhere and
Got.
work. So yes.
All right. Thank you so much. I think we'll stop here, and I think it would be lovely to have some, frequent, occasional sessions on mathematics, especially pure mathematics, since that's your interest. So, those of you who are here today, if you're not on the Discord server, I will just put the link in the chat in a minute. But otherwise, if you're interested in mathematics in general, please give us more ideas. And if you would like a club, and mathematics club that could meet maybe twice a month online, I think that would be a good idea for all of us. So,
Yes, yes, I completely agree with you, Sitara. And one more thing which I would like to say that right now, like we are as students who are pursuing BSc or BA for that matter, we need to think about how we can devise new ways. We need to think out of the box. And I believe that earlier we had green revolution, we had white revolution, we had so many revolutions, but now it's time for us to start off a research revolution. All of us think we did wrong or right, that is something which we should not bother about really. But what we should think, what we should work upon is your ideas. You need to respect your ideas and you can come up with the most brilliant theories possible. So with that, like that is what I wanted to add to you, add to your point. Yes.
thank you for sustaining your curiosity. I think it's very inspiring to see someone with a fresh perspective. And yeah, from my side also, I would like to, highlight that like it's not like you need to know absolutely everything before you can start working on something that is your own idea. If you ask a question, and you start attacking that particular problem, you will learn what is necessary along the way. So I think this is a important idea to convey to everyone in their, especially in their high school or undergrad years. So thank you. All right, so we'll
Thank
end
you.
here. Thank you so much for joining us today, and we'll definitely have more sessions in the near future.
Thank you, everyone. Thank you very much. It was really an honor.